Okay, here we are going on to the next one on page 5. We will look at this one here where we need to do a subtraction inside the parentheses before we square this. And we do need to find that common denominator. So with 3 and 2, since they're both prime numbers, you're just going to have to multiply them together to get the appropriate least common denominator. So our least common denominator will be 6. So for 1/3, to try to get that into 6ths, we're going to multiply by 2, top and bottom. And for 1/2, we're going to multiply by that 3. So if I come back to my original problem, then I'm going to have 2/6 minus 3/6. Then it starts to become a little bit of a tongue twister. So think about this as adding the opposite. So we would have negative 1/6. Remember, once the denominator is the same, do not do anything with it. We're not going to add it or subtract it or anything. We're just leaving it alone. And the numerators do all the work at that point. So we say 2 plus negative 3, and then we end up getting a negative 1/6 in there. And when we square that, because it's all inside the parentheses, that will become positive, and it will become positive 1/36. Okay, let's see. All right, so for this next one, I'm going to go down, and then we'll go over to those last two on this page, because there's pretty much an important thing on each of these I want to make sure you have looked at. So this next one is nice because we already do have a common denominator. So I'm just going to be saying 1 plus 3/2 times y. Because they're common, like terms, as well as having a common denominator, I can go right ahead and add those. So that's going to be 4/2 y, or we'll end up simplifying to 2y. So if one of those things was not the same, then we would have to do some transformation on this first, do a costume change. But because y is the same power in each one, just to the first power, the denominators are the same in both, so we can just go ahead and do that addition. Okay, now I would like to look at the one here in the middle, the 4 divided by w times z for those two values here. And this is a really good one to look at as far as order of operations. Remember, when you're substituting something in, you're always putting it inside parentheses. And that takes care of making sure that each number is being affected by the appropriate operations. So in other words, it means that if it's being subtracted or squared, or we're taking a square root, or we're doing the absolute value, then it will get that operation attached to it when I have them put it inside parentheses. Okay, so I'm going to make this to 4/1. And at the same time that I'm doing that, I am noticing that if I refer to my checklist of pandas eat mustard with dumplings and apples with spice, the parentheses I have are only to do that substitution. So I can cross those off my list. There are no exponents, so I can cross those off my list. So the next thing I'm going to be looking at is multiplication and or division in order from left to right. So as I scan through this problem, I'm going to do this piece right here to begin with, because that is the next thing in my order of operations. And when I divide fractions, I really don't divide them. I rewrite them using multiplication. So we change it to multiplication, and we flip the second fraction over, so it becomes 7/2. And then we're still just going to multiply that, multiply by negative 1/5 down. That's just going to copy down to the next line. And I'm still working with that very first operation, because I always want to go in order from left to right. And I'm going to multiply those two things together. If you notice that you have a common factor of 2, you can divide those out. So we'll actually get 2 times 7/1. So 14/1. And I'm just going to leave it over 1 because I know that I'm about to multiply it by a fraction. and that will keep everything in nice rows for me, for my eye to follow. But you wouldn't have to put a 1 underneath the 14 because it is a whole number. So moving up over here, I'm going to rewrite that so it looks a little nicer. 1/5, great. So, and then multiplying, remember that's the easy one. We just multiply the numerators together, multiply the denominators together. So we'll have negative 14 over 5. 5 is prime. And the reason I'm thinking about that is because I want to see, are there any common factors I can divide out? But 14 is not divisible by 5. So this would be the simplified form if I'm okay with an improper fraction. If I am not, then I need to change it, do that long division, and we'll get negative 2 4/5. Okay. And then this last one down here with all these x terms. Sorry, make some space there. So looking at this one, I want to make sure that these can all be simplified into a single term. And the way I'm going to notice that is are they all having exactly the same variable part? This one has an x next to it. This one, the x is in the numerator, and this one, the x is next to it. Okay, in the numerator or next to doesn't make a difference. It just can't be in the denominator. That's not the same. So all three of these are like terms, and because they are fractions, I do need to find that common denominator because it's addition and subtraction. If it was multiplication and division, I could just go ahead and do it. Wouldn't make a difference. But it is not. So I am going to look off to the side here and think about if I have 5, 10, and 15, what might a good common denominator be? And I'm going to build that by looking at those prime factors. I'm going to need a 2, a 3, and a 5 in there. And I only need one of each, because I take the highest power that I see in the column. The highest power on each of these is 1, so I just keep the 1. And then that will be 30. Now this is something that you may have been able to see by looking at these and knowing the multiples, the multiplication tables that you do. And if you do, that's fine. You don't have to build it. But knowing how to do it can make it easier when you look at more general situations when we need to use those variables. So I'm going to put my little curtain here again. So 30ths, that means we've got to change every single one of them. So we need to do the 4/5 to 30ths, which will be multiplying by 6 top and bottom. So this becomes 24 30ths x. And then the 3/10, and you don't have to worry when you come over here behind the curtain to do the costume change. You don't have to worry about adding or subtracting. Just make sure you put it back in here correctly. But for right now, we're just wanting to make sure that the numbers are correct, that we're going to have a denominator that's 30 and the corresponding numerator, which will make these two still have the same value. So 9/30ths, so I'm going to change that to adding the opposite of 9/30ths. And just for continuity's sake, I am going to put that x off to the side. So just so all of those terms will look the same. And then the 1/15th, we have to multiply by 2 to get that. So this would be 2/30ths x. So now I can go ahead and add those together. So it'll be 24 plus -9 plus 2 all over 30 times x. Let's see, that's going to be 26 minus 9, which is, what, 17? Let me double check my... Yeah, 17/30ths. And this is another situation where it's, if I know that immediately that 17 is a prime number, then I know that there can't be any factors I can divide out there. There's no common factors because 30 does not have 14 as one, or 17 as one of its factors. All right, so moving on to the next page, and that is going to be looking at a little bit different situation because we've been looking at expressions up till now, and we are going to be looking at solving equations with our fractions in there. So we will look at the note here part, and then I will do the example portion when I come back from an appointment I have with my son. So, all right. So what we're going to be doing here, and I really do recommend this method, is, put a star at it, something. We are going to be using this for the rest of the semester, I'm sorry, for quite a bit here in our class, and then also in Math 40, and this is going to be used. So you may decide to not use it right now, and that's all right, but know that this will be coming back in Math 40, and the sooner you're feeling more comfortable with it, the better. So it may be useful to multiply the entire equation, or whole equation, by the LCD of the fractions, the least common denominator. Once you do that, all those fractions should be gone. So it's really nice because it gives you all integers in this situation. And then we follow up. That's the new thing. That right there is the new thing. And then the rest of this is just how we have been solving equations as we've gone on from the beginning of the semester. So simplify both sides with order of operations. So do any distribution and collect like terms. Choose the side you want your variables to end up on. And then add or subtract terms to get the variables on one side and the constants on the other. And then, end up with dividing or multiplying to get the variable by itself, multiplied only by positive 1. All right, and I am going to pause that one here, and I will do the examples when I get back. Thank you, guys.